Welcome everyone to my channel. Today we have a challenge on the board. It's math-oliped challenge, math-oliped question. So how do we solve this? But before then, if you're new to this channel, kindly subscribe. And when you subscribe, turn on the bell notification button. Okay, so let's take a look at this question for the day. The question says 3 to the power of m minus 2 to the power of m equal to 65. What there will be the possible value of m? Okay, without much waste of time, let's take our question and put down the solution. Let's put down the question, which is 3 to the power of m minus 2 to the power of m equal to 65. Okay, now if you look at this question carefully, this may pose some challenge, but we're going to solve it with the knowledge of mathematics we gained in the previous classes. All right. So how do we handle this challenge? It is easy. What we want to do here is to see how we can bring in another alphabet. But before we can bring in another alphabet, in here, we must either deal with the exponent or deal with the base. Okay, but here let's handle the exponents. If I decide to square this exponent, or if I decide to square everything here, it means I must also square this. So I want to introduce the square without introducing square to this other side. And so I can rewrite this expression here as 3 to the power of m or to the power of 2 all over 2 minus 2 to the power of m or to the power of 2 all over 2 equal to 65. Now take a look at this. Here we're having 2 all over 2 will give us 1. Then 1 times m will give us m. So 3 to the power of m is still the same thing as whatever we have here. All right, so let's go up to the law of indices, which says that if you have something, an expression of this kind, that you have a to the power of m or to the power of n, this is equal to a to the power of m n. Okay, in some of our videos we talked about this law in many occasions. Okay, so if we succumb to this law, we can bring in this fraction here. We can bring in this fraction here also, and so we can rewrite this as your 3 to the power of your m all over 2 close bracket all to the power of 2 minus same thing we have here m all over 2 all to the power of 2 equal to 65. Easy. Okay, so we now have a square here, we have a square here. So we can bring in different letters to represent what we have in the bracket here and what we have in the bracket here. Because what we have in here and here are different, so we are bringing different letters. So we cannot say here, let's take x be equal to our 3 to the power of m all over 2. Then we have take the second one, y equal to 2 to the power of m all over 2. Okay, so let's proceed from here. So let's go ahead and put this x into here and y into this position. So if we do that, we're going to have this to be this now implies x squared minus y squared equal to 65. Wow, the game is playing out now. All right, now let's look at this again. Here we can apply the difference of 2 square because we are having x squared minus y squared. So the difference of 2 squares says that if you have your a squared minus b squared, this is equal to a plus b close bracket a minus b. So if we succumb to this rule, then we can rewrite this as our x plus y close bracket, then bracket your x minus y close bracket are equal to 65. Good. Let's take down this again. Now, if you look at this expression here now, we can subscribe to this product rule. Okay, but here we must get two numbers from here that we can equate these two. And so we look at 65. We can rewrite 65 as 5 times 13. And so this will now becomes bracket your x plus y or into x minus y equal to 5 times 13. We can equate this to the first term here, equate this to this. But if you take a look at this, here we are having a plus. So the sum of these two numbers must be greater than the subtraction of these two numbers. And so we have to rewrite the expression we have on the right hand side. So our expression will now becomes your x plus y bracket x minus y equal to 13 times 5. With that, this now implies that x plus y equal to your 13. Let's take this as equation 1. Then your x minus y equal to 5. Let's take this as our equation 2. Now, if you look at these two equations, automatically this is a simultaneous equation. So we can solve these two equations simultaneously. How do we go about this? Now we're having x here, the coefficient is 1, 1. Y here, the coefficient is 1, 1. So we can either add or subtract equation 1 from 2. But because we're having plus and minus here, so we are going to add equation 1 to equation 2. So if we go ahead to add equation 1 and 2, so let's put this, we're adding. So if we add this, automatically plus y minus y will leave the system. We give us 0, so we're left with 2x equal to 13 plus 5 will give us here 18. Divided by 2, then this will give us here 1, 1, and here 1, here we have 9. So we have, therefore, Rx is equal to 9. Easy. We've gotten our x, so let's go ahead and get our y. We can put y into either of the equation, but let's take equation 1. Okay, so from here we'll say put x equal to 9 into equation 1. Look at our equation 1 here. So let's proceed again from here. Okay, what does that mean? Wherever we see x, let's put in 9 there and just simplify. So our equation 1 is your x plus y equal to 13. So here we have 9 plus y equal to 13, y equal to 13 minus 9, therefore y equal to 4. Simple as ABC. But recall, there's a place where we said, let your x be equal to. So from here, we now recall where we said, let x be equal to 3 to the power of m all over 2, and y equal to your 2 to the power of m all over 2. So we succeeded in getting these two numbers now. So we want to get the value of our m from here. So let's take the first one. The first one, we have case 1 where we have our x equal to 9. So looking at this will now give us 3 to the power of m all over 2 equal to 9. We are having base 3 here, so we can equally express 9 as 3 to the power of 2. Okay, so the bases are now the same. And so this, we go with this. We now have m all over 2 equal to 2. This is all over divisible 1. So if we cross multiply, then this will now give us, therefore, m is equal to your 4. This is the value for our m. Now, if we go ahead to substitute 4 for y into this expression here, we are still going to get the value of m to be 4. But what we want to do here is this. We want to check if the value m correspond or will satisfy our equation. So here we want to check. All right. So we want to check here now, okay, that we solve our m equal to 4. So let's bring down the question. Wherever we see m, let's put in 4 there. So this will give us 3 to the power of 4 minus 2 to the power of 4 equal to 65. What is 3 to the power of 4? That is 3 times 3 times 3 to 4 places. And that will give us what? 81. Okay? Then minus 2 to the power of 4 means 2 times 2 times 2 times 2. That will give us 16. Okay? Equal to 65. Then 16 from 81 will give us what? 65, which is equal to 65. So this shows that the value of m, which will solve for to be 4, is what? Correct. Q, E, D. So if you learn something from this math Olympiad question, the solution to this math Olympiad question, then drop it in the comment section. If you love what is going on here, do not forget, do not hesitate to share with family and friend members who need this knowledge of mathematics. Remember, this is Online Maths TV, and every one of us love you. Most especially, Jakes loves you so much because you are always there. Bye for now.